Good morning or afternoon, everyone, depending on which part of the country you're in. Welcome to today's Construction Supply Group webinar with Muscle. I'm Vicki Strand. I'm your Director of Marketing and Communications for Construction Supply Group. We're excited to bring you this new product offering. CSG is here to support all of your construction-related challenges. We are here to support you and find effective solutions in saving you time, money, and labor. We have over 140 locations across North America to handle all of your construction project needs and look forward to working with you alongside Muscle. Before we get started, we would like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks like this on your own computer in the upper right corner. When you join today's webinar, you selected to join either by phone call or computer audio. If for any reason you'd like to change your selection, you can do so by accessing your audio pane in your control panel. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time. We will collect those and address them during today's Q&A session at the end of today's Muscle webinar. I'd like to introduce today's presenter from Muscle. George Doyson is Vice President of Business and Strategic Development for Muscle, with responsibilities for marketing programs, brand management, and company sales. George's strong experience and understanding of the flood control, water containment, and control markets serves Muscle and its clients very well. Prior to joining Muscle, he directed strategic business development and marketing for several companies, as well as serving our country in the U.S. Army. His last position was an artillery fire direction officer for the 222nd SA Battalion. George lives in North Salt Lake, Utah, with his wife, Allison, where they enjoy snow skiing, mountain biking, water sports, and adventures in the mountains. Thank you, George, for presenting with us today.
Thank you, Vicki. I certainly appreciate the opportunity, and thank you for your kind comments. We certainly have enjoyed working with CSG and the many organizations that are part of the CSG family. So thank you again. A couple of things just to some housekeeping issues. This is a presentation that is a general overview. Any participants that would like focused information about certain areas that we deal with effectively with flood and stormwater and containment and so forth, we're happy to do individual focused presentations and webinars for organizations within the CSG family, along with municipalities, county government entities, and any organization that would feel benefited by this information. Muscle is a focused company with an initiative about resiliency. Being resilient is a very popular buzzword in today's environmental issues, flood issues, and in containment. But we recognize that as much as it is a buzzword, it's something incredibly important. We believe very strongly in preparation. The FEMA has stated very clearly that for every $1 spent on preparation, you will save at least $6 on reparation. And so that's something that we focus on, and Muscle is designed to be part on the front side of those types of risks. And so we're definitely focused on that. This is part of our initiative and part of our mission statement. I'm going to go ahead and share with you an overview video to get started. It's a great video that gives us a nice snapshot of some of the many applications where the muscle wall system has successfully engaged different applications. This slide really well identifies the modularity of the muscle wall system. As you observed this slide, you could see the muscle wall sliding into place, well identifying one of the components of the muscle wall system, which is a sliding joint. That sliding joint allows the muscle wall to jump over obstructions and deal with different types of rolling and undulating terrain. What you'll also notice here is that the muscle wall system, what you actually won't notice at the joint is there's actually some flexibility at the joint. There's a 22-degree flex of the joint, which allows for all types of meandering around obstructions and just dealing with different dynamics in different applications. This is a very important slide, probably one of the most important slides that you will see in the presentation today. It really well identifies what muscle wall is. Ultimately, muscle wall is a mobile retention system. You can see in this slide, it's addressing some of the dynamics that muscle wall deals with in all types of applications, the force and the pressure, the force going up against the muscle wall, and the pressure that goes down towards the toe. What you don't see in this slide is that we would use some type of a covering, depending on the application. If it's a flood protection or flood management scenario, we would use some type of an impermeable membrane or liner. If we're dealing with a stormwater application, we'll generally use some type of a geotextile. From the very inception of muscle wall, we always focused on simplicity. So as much as we are always looking to innovate and increase the design and strength and the capacity of the system, we're always focusing on simplicity. So this slide is a great example of that. You can see that the muscle wall is inverted on itself for storage and for transportation. These are all the members of the muscle wall family, all the way from the left of our road crossing, 6-inch drive over, all the way up to our 8-foot muscle wall. And we'll talk about some of these systems throughout the presentation. We recognized early on in the design of our system, as we focused primarily in the beginning on flood protection, that as much as heavy equipment would speed up the process, we knew that all of our systems would need to be deployed by manpower alone. So all of our systems, once they're on location, can be fully and completely deployed by manpower alone. This slide and video represents some of our very early testing that we did in the very beginning and the inception of Muscle Wall. These tests were done at and in conjunction with the Utah State University Water Lab, which is an Army Corps approved water lab. We've also been tested and proven in real world applications, and recently went through the industry standard for flood protection test, which is done with the Army Corps, FM approval, and ASFPM. And this video that I'll be showing now is footage from the completion and the success of that recent test. We take a great deal of pride in the results of that test that we recently completed, even though we had have done these tests over the years to continually test the abilities and the success of the system. That certainly was a big deal for us, so we take a great deal of pride in that. There's always going to be some type of a conversation at some point about logistics, transportation, cost, and so forth. And so the next several slides, I'm going to show you some pictures of the Muscle Wall being fully on full loads of transportation. This is a full load of our 2-foot product. That's 1,536 linear feet or 256 units. That's going to be about $50 per linear foot, or just over $80,000. This is our 3-foot Muscle Wall truckload, 192 walls, 1,152 linear feet, around $75 per linear foot. It's going to be just north of about $85,000. And then this is a full truckload of our 4-foot product, 576 linear feet, about $100 per linear foot, or just over $60,000. Keep in mind, these are full truckloads. Obviously, with different applications and needs for customers, that we would design truckloads or multiple truckloads to meet the individual needs of each customer and application. This just kind of gives you a snapshot of the different sizes, linear footage, and cost, and so forth. This is I like to share this slide for multiple reasons. This is actually an application where the customer needed some type of a washout space to protect against environmental risks. And so it definitely is something that we used in a live application. It also exemplifies some of the other components and important design pieces of the Muscle Wall systems. These are multiple systems being connected, and we've not only in this particular application, but we've had other applications where we needed to utilize different heights of Muscle Wall to successfully engage the dynamics of an application. So what you see here in the front is our 6-inch drive over, which allows for equipment and vehicles to drive into this space. Then you see the 2, the 3, the 4, and the 6-foot Muscle Wall, all interconnected.
Begin by setting your first wall in place, and then subsequently sliding each 6-foot section in place using a coupler joint connection on the end of each wall. Once a section of walls have been set into place, you'll want to begin filling each unit. Insert safety ratchet straps through the kiss screws. With the 2-foot Muscle Wall, only 1 strap is used. With the 4-foot Muscle Wall, 2 straps are going to be used. one through the middle of the wall and one at the top. At this time, only secure the top strap on the 4-foot wall. The liner is then deployed over the muscle wall system. On the back side of the system, cut a small horizontal slit in the liner. Pull the non-ratcheted strap through the slits and then tightly secure them down.
As you can see from that video, muscle wall is a very simple system to deploy. There's a couple of components in that video that are important to note. Obviously the liner is important. Depending on the type of application, we would use a different type of a liner to deal with the dynamics and the risks of each application. Also, the 2, 3, and 4-foot muscle walls are hollow, so we do fill them with water. And those are some important things to consider and to certainly be aware of. We're going to jump into some of the very specific applications that we have engaged successfully and focus on. The 3 areas that we'll be focusing on primarily for the rest of the presentation are going to be flood control, containment, and then stormwater erosion control. So this next video focuses on the flood protection projects, the flood control projects that we've worked on.
Alton is used to dealing with floodwaters, but this year the mayor tells me they're implementing a new system to try to help protect the town. Now the mayor says it's really being put to the test since they didn't expect waters to crest quite so high.
What started off as maybe a moderate to a minor flood, we are now in a major flood category with a crust in the city of Alton of 35 feet.
Mayor Branch Walker says that's 16 feet higher than normal, putting a lot of pressure on the new muscle wall. Mayor Walker says it also takes less time to set up and less manpower to maintain, ultimately costing less tax dollars while still protecting the downtown.
Floodwaters puddled out onto State Street. A 3-story building was right in the middle of it. Sandbaggers fighting a losing battle with floodwater.
We were right there on the edge. I mean, it was inches from entering the first floor.
To the rescue, muscle wall. Their invention can be floated into place, filled with water, and sunk. The barrier quickly surrounded the building and eliminated the need for thousands of sandbags.
The whole wall was built within 2 hours. If it weren't for muscle wall, there's no way we would have saved the building.
This morning, Julia Davis Drive is closed. That's in preparation for a wall to be built around the zoo. KBY2's Lauren Clark tells us why zoo staffers are now seriously concerned about flooding and why the city chose a wall over other options.
Kelsey and Brian, you guys can notice these materials here behind me used to build that muscle wall. If the zoo does have to evacuate those 200 plus animals, they would only have about 24 hours to make all of them move. And that is a logistical nightmare. Moving 200 animals would not only be costly, potentially more than $500,000, it would also be difficult. The animals could be stressed during the move. That's why the city says a muscle wall is a very worthwhile investment.
I think it would be a more prudent, reasonable task to just go ahead and put in the muscle wall system now and hope that it's actually for nothing.
This wall will only take about 1 to 2 days to be completed, but it will stay until flooding is no longer an issue.
That video does a very nice job at focusing on a lot of diverse scenarios, but primarily really well defining critical infrastructure. So as you could tell in the video, you saw utility substations, you saw different communities, and in one case we showed the zoo, actually in Boise, Idaho. And I always kind of get a little bit of a chuckle out of this. One of our customers in Canada focused on protecting the hockey rink versus the city hall. So the hockey rink was more important. So ultimately, critical infrastructure can be defined in so many different ways. But I think the most important thing is whatever that might be, we have successfully engaged those important issues and risks. So in continuing in the focus of flood and talking about critical infrastructure, I want to talk to you about some of these other critical infrastructure components. This is a slide that I utilized many, many years ago. We've done a substantial amount of work in California, working primarily with state agencies, Department of Water Resources, Department of Emergency Management. And in this presentation, the additional stakeholder, along with these state agencies, was the Army Corps of Engineers in the Sacramento district. So ultimately, what this picture is telling you is it's a conversation about levees and what's inside of the levees, the critical infrastructure, homes, communities, commercial assets. So the conversation was focused on what do you do with the levees when you've got overtopping? So we were involved in the conversation about engaging either in a permanent fix, so basically increasing the height of the levee with a permanent, more earthen scenario, or looking at a temporary solution. And so we got involved in the conversation. And really the focus for us is flooding, as often as it might be, is still a temporary problem. So why change the levee permanently when this is only a temporary problem? And so here's a replication of what Musselwall does to a great degree in California as a levee overtopping solution, or as the state of California affectionately calls Musselwall instant freeboard. So part of this conversation is kind of a multifaceted discussion. Obviously, we're talking about overtopping. So Musselwall can and has done an exceptional job at mitigating that risk. One of the other things that Musselwall does that permanently increasing the levee will not do is mitigate erosion. And so along with the actual Musselwall system sitting on top of the levee, if you can see my cursor here, we would also add the liner over the top and drape the liner into the levee system and sitting between the levee and the water, which creates an erosion control and risk benefit. These are some of the slides, pictures from training that we do regularly with the Department of Water Resources and their flood fighting specialists. It is always interesting to me when this slide pops up. Sandbags are still the #1 used flood protection solution in the United States, which is always a kind of an interesting conversation for sure. But nonetheless, it is what it is. And so let's discuss that and address that effectively. So ultimately, what we're talking about here is temporary flood protection. Sandbags, on their very, very best day, are a temporary flood protection. So as a comparison, this is also kind of is in conjunction with the video that we saw just a moment ago, where the gentleman said if it wasn't for Musselwall, we would have lost the building. That particular building had 600 linear feet of protection need. They needed 4-foot high protection, and so we engaged the 4-foot Musselwall in that particular application. If they were going to successfully engage this 4-foot high sandbag wall, it would have taken them 2 to 3 days to effectively do that, and well over 100 laborers to do that. We were able to successfully engage the Musselwall, 600 linear feet of the 4-foot muscle wall with 8 individuals in less than 2 hours. And just as the individual explained, if it wasn't for muscle wall, they would have lost the building. There were 2 adjacent buildings in that area that were engaging the flood fight with sandbags. Neither of those buildings still exist. In fact, ironically, I was just in that location recently, and it was just kind of a stark reminder of the difference with a system or an application that works. This is what it looks like from a real world scenario. 468 sandbags for each 1 4-foot muscle wall. So if we toggle back and look at the costs, the true cost of sandbags with all the things included, logistics, transportation, all those important individual components, and depending on the labor expense, you could be between $2.50 and $5 per bag. The muscle wall is only going to be about $1.25 to $1.30 equivalent per bag, and most importantly, we're reusable, more sustainable, more resilient, and ultimately will cost you in the short and in the long term, will save you a significant amount of money. As I've noted a few times, we use some type of a covering depending on the application. Obviously, we're focusing on flood in this area, so we're going to use some type of a liner or membrane. I won't go into great detail about each of these particular pictures, but please note that we're dealing with different surfaces, either soil, concrete, or asphalt, or a combination of those, and we have and can successfully deploy the liner or membrane to reduce and or eliminate any level of seepage.
For years now, the method of choice for secondary containment has been earthen solutions. These solutions are expensive, require the use of heavy equipment, and present significant environmental concerns. Muscle wall was engineered and designed to provide superior secondary containment without the common issues that are prevalent with earthen solutions. The beauty of muscle wall lies within its sections. By having multiple 6-foot wide sections, it can be configured to meet the needs of our customers. The corner units allow for a 90-degree turn and the ability for square containments. The 22-degree range of motion at the joints allow for circular or curved containments, as well as the ability to bend or curve around terrain or equipment. While designing muscle wall, one of our biggest goals was to create a product that can be quickly deployed. Time is money for our clients, so we want to be able to provide them with the most reliable product on the market that can be set up and taken down in as little time as possible. The lightweight of each wall, coupled with the intuitive design, allows muscle wall to be deployed and taken down with just a small team of workers and without the aid of heavy equipment. A 2-foot secondary containment big enough to house a standard frac tank can be set up in less than 30 minutes. Muscle wall was designed with the environment in mind. By using muscle wall as a secondary containment, negative impacts to the environment, such as erosion, are greatly reduced. At Muscle Wall, it is our desire to help our clients be responsible and exceed all standards and environmental regulations.
So obviously we're talking about Muscle Wall as we have engaged successfully the containment space. Most of our experience in containment has been directly connected with the oil and gas industry. We also have worked in different industries like agriculture. But we'll focus today a little bit on most of the applications that we've dealt with over the years. We've now worked in the oil and gas industry now for close to 11 years. To preceding Muscle Wall's engagement in the oil and gas industry, the industry primarily engaged earthen type solutions, very archaic, very costly, and ultimately costly inefficiencies as well. One of the challenges in the industry is the reliability of the frac tank systems. They generally are very unreliable. And so when they were using the older solutions, the earthen solutions, it would take several days to demobilize a frac tank that was now not functioning. And with the introduction of the Muscle Wall system, that changed significantly and also changed some of the costs that they were incurring because of the inefficiencies. Some of the things that are important to note, not only from a secondary perspective, but we also have done quite a bit of work in the primary containment space in the oil and gas industry. And I just want you to focus on some of the key pieces here, just overall efficiencies. So the more they use the system, here you see the first system was set up in 7 hours. This is a 200 by 200 4-foot high containment system, 25,000 barrels of fluid. This very next time, so these are individuals that have never used the system before. Very next time, literally cutting it in half. So being very efficient in time, cost, all those types of things. And in any type of a scenario, if you can save money, save time, it's always worth considering. This is our 6-inch drive-over system that you're seeing here. We designed the system several years ago, initially at the request of the oil and gas industry, primarily because of the systems that were being used at the time and also are being continued to being utilized. There are foam type solutions. The challenge with foam solutions is that it does provide a level of containment, but once the vehicle actually drives into the containment and actually depresses the foam, you actually lose the continuity of that containment. So our system was designed, it's a hardened system. It still allows people to drive in with their vehicles or equipment, but you always can maintain full containment continuity, regardless of whether the product is inside or driving into the containment area. This is another addition to our family of products. This is our drive-over road crossing system. This allows for protection of utility, conduit, pipe that needs to traverse some type of a road crossing. This slide here shows one of the tests that we did to test the capacity. I think ultimately during the test, they were more concerned about whether the tire would blow up versus the risk to the muscle wall system. But during all of these tests, muscle wall did very, very well. Shifting gears here a little bit to focus on muscle wall and the application of stormwater management. That's one of my favorite videos for a lot of different reasons. I use it quite a bit with training with customers, but it does a lot of great things. It shows efficient, effective deployment of the liner on multiple surfaces. You see the introduction of the liner clip and just dealing with lots of different scenarios. So all the footage of this video and this, including this picture here, was done on a project that we did in conjunction with Lennar. Lennar is, I believe, currently the third largest developer in the United States, and we've done some pretty substantial projects with them. But ultimately, what was going on here and throughout the project is that they were running a great deal of risk dealing with traditional BMPs, silt fence, straw wattles, and hay bales, and ultimately were just rendered ineffective. Stormwater basins, detention spaces were being inundated. It was creating stormwater violations because of discharge. There was flooding events because of inundation in detention spaces. And so at the introduction of the muscle wall system, we were able to successfully engage Lennar and their development partners in mitigating those risks and providing just a better BMP to get the job done. This picture here, what you don't see in this picture is to the upper left of this picture are the mountain areas of Southern California. This is the El Toro Marine Base space that was a decommissioned Marine base. And this whole development right there in Irvine, California, was to develop commercial and private properties. So you see, what you see in this picture is muscle walls doing two things. And primarily, and certainly the focus of this conversation is effective stormwater management with an effective BMP. But in a secondary scenario, and to some level of equal importance, you see this building to the right. That is an old aircraft hangar from World War II. It's part of a museum that the old Marine base maintains to protect history from this location. And ultimately, the muscle wall in a secondary mode was protecting that aircraft hangar, which houses old World War II aircraft. This is another project that we engaged with Lennar. This is actually up in the San Francisco Bay Area. This is Treasure Island, Yerba Buena Island, or YBI. Some of this project had some very aggressive slopes. Once again, they were using traditional BMPs to deal with discharge risks, environmental risks, stormwater risks going into the San Francisco Bay. We're having a great deal of problems. Traditional BMPs like the silt fence, straw wattles, and hay bale were just not working, just not effective at all. And so Muscle came in and did a variety of things on this project, and I'll show some additional here in just a moment. But ultimately, we're very effective in managing some of the erosion and stormwater discharge runoff risk in this particular project. We also have done a lot of diversion work in stormwater management. This is another snapshot picture from the El Toro project with Lennar in Southern California that was part of the initial video. We've also done work in hazardous materials and containment and control. This particular customer was looking down the barrel of about a $1 million plus fine from the EPA. The EPA did give them some time to respond effectively. We were able to support them in less than 24 hours. And ultimately, the end result was containment of the hazardous materials and full elimination of the EPA fine. This application here, as you can see, it's noting levee raising. Kind of goes back to the initial conversation with flood protection. I actually like this slide for that reason, also for additional reasons. You wouldn't note this from the inception of seeing this picture, but this is actually another great picture of muscle wall providing the protection of critical infrastructure. What you don't see in this picture is a municipal golf course, which is actually off to the left of this picture. About 4 years ago or more, That particular golf course was heavily inundated with floodwaters, virtually destroying most of that golf course and eliminating the revenue. That particular golf course provides at least $3 million annually to this particular municipality, which is very important, very significant to the success of that particular municipality. And so, as was noted in the original flood video and also discussing here, critical infrastructure means a lot of different things to different people, communities, and municipalities and federal government. We've also done some work in the coastal erosion space, coastal protection space. This particular picture is actually 4 years old. The mussel wall is still being utilized in this space for coastal erosion. Previous to this picture, this coastal space had dealt with well over 60% loss of coastal space. And in many situations, these properties, these coastal properties, were running the grave risk of literally dropping into the ocean. And so mussel wall came in, we engineered and designed the system to be able to effectively engage this risk. And so we've had some great success in the coastal erosion space as well. This picture here goes back to this project, this other project I mentioned with Lennar in the San Francisco Bay Area. We have done multiple things with our product on that particular project. This particular application has several benefits. Primarily, it's doing erosion control. So you can see, if you look closely into this picture, you can see a geotextile over the mussel wall system, which provides some erosion protection, some sediment discharge protection into the Bay Area. It also is providing some retention. So a little on the top side of this picture, what you won't see is about another 1,500 linear feet of this 4-foot product. And it's literally sitting on the very edge of the bay. The only thing between the bay and the mussel wall is a line of riprap. But once again, it's providing that perimeter control, perimeter protection for a very important project, very high profile project. This is also from that same project with Lennar in the Bay Area, providing some sediment capture to once again reduce and or eliminate the discharge risk into the bay. All right, that is it for the presentation. I really appreciate the time that you've taken. I know that everybody's time is valuable. This is my contact information. Once again, I'm here to support CSG and the CSG family of companies. If you have any questions, this is the time to ask, and thank you again for participating. Also, I will note that if you would like a PDH certificate for attending this course, please work with the CSG folks. We'll get you the information for you to be able to, for us to be able to provide a PDH certificate for you.
Awesome. Thank you, George. Wonderful presentation and information today. As we stated earlier, we are now going to begin answering questions that you submitted during today's mussel wall presentation. As a reminder, you can still submit questions through the questions pane in your attendee control panel. All right, George, a couple questions here. Is mussel wall sustainable with overtopping?
Yes, and so if you remember the video that I showed you from our recent testing, that is a very important benefit to the mussel wall system. Not only is it sustainable to the very top, but it also is sustainable during overtopping. So yes.
All right. Can mussel wall be installed on uneven ground?
Yes. We do, it's important to note that we look at each application individually, but historically we have done quite well in being able to design the system for applications that have uneven surface or even rolling terrain. So yes, we can and have done so.
Perfect. A couple more here. Is muscle wall intended to be temporary, long-term, or both?
Both. So that's really one of the keys. The muscle wall system in its manufacturing has a UV inhibitor, which allows for the system to be deployed or reused or deployed for long terms. We have muscle wall that's been out on location continuously now for just right at about 10 years. So yes, for temporary and long-term type applications.
All right, great. What is the lowest height possible? We have drainage problems in several areas in Northern California.
So we can do, our lowest product is 6 inches. What I would suggest is let's talk with, let's take a look at the particular application with the drainage and see if the 6-inch will be suitable. We do also have the 1 foot, so our lowest is 6 inches.
All right, great. One last question here. How long does it take to set up and take down the muscle wall?
I would say depending on, there's going to be some variable issues here, depending on, if the people deploying it have used it before and deployed it before versus first time using it. I would say that with an experienced team, you should be able to deploy about 100 linear feet in about 30 minutes.
All right, very good. All right, those are all the questions that we have for today. I'd like to thank George and the Muscle Wall team for providing this webinar training opportunity, and to thank each one of you for attending. You will receive your Subway gift card within the next few days via email. Once you exit today's webinar, you will also receive a short survey on this presentation. We would appreciate your feedback, and if you would complete that, that would be great. You will also receive a follow-up email with a recording of today's webinar. On behalf of Construction Supply Group and Muscle Wall, we'd like to thank you for joining, and have a great rest of your day.
Thank you, everybody.